Hi everyone. Hi everyone. It's fantastic to be here for the 2022 National Landcare Conference. I'm here representing a small landcare group called ACT Urban Woodland Rescue. I haven't started yet, okay. Good to go? Okay, lovely, thank you. Hi everyone, hi Landcarers. It's fantastic to be here for the 2022 National Landcare Conference. Just having a little bit of trouble with the slides here. There we go, we're all good to go. So I'm here representing a landcare group from Canberra, a small landcare group called ACT Urban Woodland Rescue. And I'd like to tell you a little story about an ecological restoration that started 3 years ago by a group of neighbours who didn't know each other and decided to save their declining suburban park by restoring the original plant community that once inhabited it. The yellowbox Blakely's red gum grassy woodland plant community, a plant community that covered the fertile valleys of Canberra where many of its suburbs now stand. And you can see in that satellite shot my wonderful neighbours' homes surrounding the park. So this story began in early 2019 when I just made a casual inquiry about a grass, the grass you see pictured, which had covered the park. It's called African lovegrass. It's an ecologically transforming weed, and ecologically transforming weeds are more serious than other weeds because they interfere with ecological function. In this case, the birds can't eat the seeds of this grass or use the grass to build its nests. It's also highly flammable. So having received that information, I had questions like how were we going to remove this weed and what was meant to be in its place? So I found myself reading academic journals on the subject, and when I looked at the park again, having read that material, I realised that I was looking at what was really a pale reflection of what was originally a beautiful ancient woodland meadow. So this moved from a curiosity to something compelling, which is really what brings me here today and what drove the project. And that is these two studies that I read. The first, which showed that hollow-bearing trees may be entirely lost from Canberra's urban green space within 115 years. And this is really important because they're keystone species in the plant community here. And the second, second study, which basically showed that Canberra's parks won't survive without the gardens. So you can imagine that I looked at my landscape very differently, having this knowledge behind me. I could see that the urban landscape where I lived was in decline. We are losing our biodiversity, and I've listed a few of the reasons here on this slide. We remove keystone species like mature trees. We engage in frequent mowing, which compacts the soil and creates extreme conditions that only grasses like African lovegrass can survive. We've lost the original plant community that protects the health of the trees because they've co-evolved together. When branches fall, we remove them and leaves, even though they perform important functions, amongst other things, by returning carbon to the soil. We alter the way water moves across our landscape. We use a lot of exotic plants which pump a lot of nitrogen into the soil, which winds up in our waterways. And I've also identified here that 90% of insects don't even recognise exotic plants as food. And it's easy to see what the consequences are that flow from that. So what is biodiversity? Well, it's the variety of all living things. Think plants, animals, insects, but microbes, fungi in the soils. And the reason that's important is because that variety is a measure of the health of an environment. And why does biodiversity matter? Well, it's all about function. The less biodiversity you have, the less function you have. And the African lovegrass is a great example. It destroys biodiversity and thereby it reduces the capacity of the local plant community to produce important ecological services. Environments are really made up of jobs, and plant communities evolve together. In this instance, our local biodiversity has done that here in Canberra, and they almost operate like an orchestra, really, is a good way to think about it. They all depend on each other, like musicians in an orchestra. They're responsible for communicating and performing in particular ways. They must achieve just the right tone. They move at the right tempo, so their activities are synchronised with the needs of others. And their capacity to work together in drought and rains has taken millions of years to perfect. Our landscapes moved very slowly. And yet if we reflect for a moment on what goes on in the average backyard on a weekend, just with a residential lawnmower and a whippersnipper, we can bring about a lot of change, and this has cumulative impacts on the health of our local ecosystems. So the beautiful box gum woodland that covered the fertile valleys of Canberra was an open woodland. It had 30% canopy cover. It was an open woodland and not a dense forest because we didn't get enough rain for dense forest. And there were mature and hollow-bearing trees and next-generation trees scattered across the landscape. The photo you can see here is of a remnant in a cemetery, which is where they're found now because it's a critically endangered plant community. There were mid-storey wattles scattered in the landscape, which flowered at different times of year to support the jobs of the different species, their capacity to perform those tasks. Now, the structure and composition of plant communities is really important. So this plant community had scattered mature trees, an open canopy, so an upper canopy, mid-layer wattles, and then this incredibly biodiverse understory where it is thought more than 40 species per square metre of plant once existed. And the open structure is really important. It allows for this incredibly biodiverse understory to exist. Think small woodland birds that are insectivorous and their capacity to hunt their prey through these open spaces. And of course, the open structure of this woodland ensures that there's enough water to sustain mature trees during periods of drought. So here you can see a map of the area where it once covered this plant community. It existed over a very wide climactic range. As you can see, it stretches all the way up to the south of Queensland, beautifully suited to accommodate climate change. So now I'd like to take you through some photos of the project. This is the beginning of the project in the small suburban park. And you can see that the single tree is a Blakely's red gum. So we have some remaining remnants, which has been estimated at least 300 years old. And the other cohort you see in the other photo, also Blakely's red gums, probably over 200 years old, with a yellow box of a similar age in the background. And you can see from what I just described that there's nowhere to hide and nothing to eat here. There's no understory, there's certainly no mid-story to speak of, and what we really had was a paddock of love grass and, of course, erosion and soil compaction. So we had a lot of issues to face when we began this project. We had to understand what we could do to confront some of these serious ecologically transforming weeds. We needed to return carbon to the soils. We needed to change the way we manage the landscape. So we needed to reduce mowing, sometimes exclude it altogether, particularly under the canopy of the trees. We wanted to track what we were doing to give us some insight as to whether or not we were progressing. So we engaged in observations of birds and documented insects and plant life as it returned. We needed to slow water through the landscape and, of course, leave fallen timber. And you know, all of these factors came into play when it came to restoring the original plant community, the soils being pivotal to this process. So I've just included a couple of photos here just to reaffirm the fundamental importance of the mature and hollow-bearing trees. This is a pair of gangangs. You can see the female with the striped breast in one photo there, and she's sitting atop a hollow that we know, even though it's forming, will not be big enough to accommodate a brood for her. But if you look at the photo on the other side of the male with the orange head, he is sitting atop a hollow that's just forming, and that's on the 300-year-old Blakely. So that branch would be at least 200 years old, and we're still waiting for it to form a hollow, and that's more likely to be a hollow that might accommodate them. And here, this slide is really to highlight the importance of regenerating saplings. And of course, most of them will never reach maturity because what we have is an open woodland structure, but they still perform important functions. And in urban areas, they're mown down. So we protected them, we prevented the mowing in these areas, and you can see them sort of coming up there. And they perform lots of functions. They accommodate a lot of insects, and you might be able to see a baby magpie from last year at the base there taking shelter from predatory eyes. And I can tell you that since the restoration began, last spring we counted at least 80 regenerating red gum saplings. So we've reunited over 100 of the native species from the original plant community with these beautiful remnants in the park. You can see a lovely purple pea on the left there, Hardenbergia violacea, which accommodates many pollinators, reptiles and small woodland birds. And on the right, you can see Bosseria spinosa, or our native blackthorn, which has a beautiful scent, accommodates many insects, and has small thorns which protect small woodland birds from larger predators. And here, this part of the project is where we started to slow the water through the landscape and actually re-establish an ephemeral creek. And we did this, some of the water coming into this creek now is coming off the road above the project, and we're using species from the understory that studies show at certain densities will extract nitrogen from the water as it enters the park. And that's important because our soils in Australia are ancient and our plant communities have far lower nitrogen requirements to the exotics that we introduce. So as part of our documentation, we've identified over 40 species of native bird that have returned to the park, that are living in the park or passing through and using its resources. You can see some beautiful tawny frog mouths there, actually a father and son. We know that they are territorial, so they're local residents. And we've also documented 11 species of native butterfly that have returned to the project, which is 10% of the butterflies in our region. So I'd like to take you back now to the park and what it was like last spring. So after a year of drought and a year of rain, when we started the restoration, you can see here that it's a transformed landscape. The place was vibrating with insects. You can see there's plenty for pollinators, there's places to hide, there are things to eat. This is one of the important species, Rhodanthe anthymoides, or chamomile sunray. We focused on the early colonising species as part of this restoration. And I'll just go back here. You can see the fallen timber at the base of one of the eucalypts there. This is looking down from the top of the park. And you can see that what we're looking at here is a textured, complex, biodiverse landscape. And families bring their children here. This is what the human eye evolved to see rather than the industrial landscapes that we tend to create ourselves. And this is just a couple of more, some hoary sunrays on the left with a lovely little meadow argus butterfly and the local rock lily. So as part of this restoration, we've had the privilege of seeing the return of some ecological relationships. And this is one example, the checkered copper butterfly, which evolved with the little plant you can see, flowering yellow plant, local clover, an oxalis. It lays its eggs under the leaves of that oxalis, and the caterpillars eat just that plant. And they depend on the little ant you can see in the bottom photo there, which cares for them, takes them out during the day to feed and herds them back into its nest at night to protect them from predators. And after a while, they'll form a chrysalis in the nest, and after 12 days, the cycle begins again and adult butterflies emerge. A lovely little relationship there, and beautiful photos from Butterfly Conservation South Australia. They were able to capture that detail that I wanted you to see today. So autumn, late summer autumn this year, you can see that we have is seasonality for the first time. We've got an abundance of seed that's developing here. You can see the regenerating saplings I spoke of, and you can see the mid-story wattle there that's growing well. And this is really important because it's a dynamic time. those long grasses will fold over and protect the soils and provide, some of the seed will provide food for local wildlife, and the rest of it will start to rebuild the seed bank as part of this restoration. And you can see some more photos here of flowers going to seed. How lovely. And to give you an idea of how dynamic this period of time is in the woodland, this is a common brown butterfly. This is a male who was photographed in November last year when there were many females in the park, female common browns, and presumably he mated, and after a month or two, his life cycle would come to an end. And at that point, the females shelter in the long grasses. Like many of our local wildlife, they've co-evolved with the particular plant species. The incredible thing about the female common brown is that she can delay the development of her ovaries and the timing of the laying of her eggs so that her caterpillars have the best chance of surviving. So this autumn, we waited for the first autumn rains, and sure enough, we saw the park fill with female common browns, having completed their life cycle, having laid their eggs at the best time, and in the ensuing month or two, their life cycle would have come to an end, and we anxiously await the next lot of common browns this spring. So I've just provided a little summary here about healthy functioning urban landscapes and what we've learnt so far from this project. Certainly, it's really important to explain to the community how local plant communities function, to plan restorations to be compatible with community use, which is not a difficult thing to do, to show people what a healthy landscape looks like so that they can feel it and experience it for themselves, to slow water and repair the soils, to use the local vegetation, to return the local vegetation and reconnect ecological relationships. Of course, to protect the mature and hollow-bearing trees, which are the keystone species in our landscape, and to plan for the next generation of trees, to be respectful of the structure of the local plant community so that what we do is sustainable. And of course, to share this information with the community so that they can use their gardens to protect the health of their suburbs and improve the health of their suburbs by planting the beautiful local native species in ways which will mitigate some of the fragmentation that we've created, which basically means the obstacles that we put in the path of the movement of seed and wildlife, like our homes or driveways. And finally, when it comes to the management of public areas, we need to focus on retraining those who engage in that work so that they engage in disruption which is of a far less frequency and a lower intensity, obviously not to remove vast amounts of vegetation, and to be to work in tune and be sympathetic with the needs of the local plant community, and of course to monitor what we're doing and to adapt as the need arises. So this is the core team who brought all this about. Obviously, fantastic scientists who produced all the work that I read, with whom I consulted, but also my wonderful neighbours, Tony, Amelia, Brad, Mandy, Damien, Irene and Diane, and extending out from the core group, lots of people within the suburb and further afield in Canberra who have just been wonderfully supportive of this project. And I'd just like to leave you now with a few thoughts of my own from the experience so far with the project. To face climate change, we need to turn to our local ecosystems and remember that they have evolved to perform sophisticated functions in our soils in response to our climatic extremes. To do this, we need to allow them to age, because when it comes to plant communities, age brings resilience. The ecological services we need, like slowing the wind, cooling the air and storing carbon, require functioning ecosystems, and permanently young landscapes of predominantly exotic plants will not prepare us to face the risks of climate change. So nature is in the city. It is in the parks and gardens, laneways and median strips of our suburbs. And understanding how our local plant communities work and wildlife function, recognising their structure and composition, allows us to see their value. Protecting them comes naturally when we understand how our survival is connected to theirs. Thank you very much.